This hour has been recorded. Okay. So if you don't want people to see your face, you can take off your camera. It will make a difference. All right. This, what we're going to do today, we're going to go through a couple of problems. But if you have any special question that you want to ask, then my suggestion is ask it now. That way, we can also answer it for the benefit of everybody. So do you have any special question that you want to ask, or any special problem that you would like to solve?
Not yet.
Not yet?
Not yet.
Okay. All right. So I'm going to pull up the class, and I'm going to look at one of your homework assignments. We're going to try to look at it. Okay. Okay. So we are actually, give me a minute. All right, so we are in actually in week 4, and so you have you done the assignment for week 3, which was due 2 days ago? Hello?
Is that the one with the Staten Island housing?
Yes.
Yes, I completed the assignment.
Okay. Are you comfortable that you did it correctly?
I'm not like too confident.
Okay. Let me go and see what happened there. And what's your name again?
Oh, my name is Tamara Janvier.
Janvier. Okay.
Yeah. Okay, let me just save it as a Word doc.
Okay, that is the ed-wage assignment, which I have begun to look at. The neighborhood problem. Okay. All right. So you calculated the averages. Okay. There is one problem that I see, which is many students, when they make charts, they plot the mean and the standard deviation on one chart. You don't do that, because mean and standard deviation are 2 different measures. There is no basis for comparing them. There's no basis for comparing them. You can compare the standard deviation of one group with another, and compare the mean of one group with another. But you cannot compare mean and standard deviation. You can't. You can use them both for some analysis, which I'm going to talk about. You can use them both for some kind of analysis, but you cannot plot them on the same chart. And this is why I wanted to hold these office hours like next week so I can explain that to students. I don't derive any joy from students doing an assignment wrong. Okay. So I'm going to go through it, and I'm going to let students understand the different meanings and why you cannot really plot the two of them at the same on the same chart.
That's why I wanted to join, because I was reading like the PowerPoint through in and out, but I still felt a little confusion. So I was like, let me just join this week's office hours so I could get a better understanding.
Okay, I'm going to do that. Okay.
Okay.
Okay. Right. The assignment. Okay, the assignment for week 4 actually is telling you to do the survey. Okay. And so I'm going to go to the assignment that you did, and I'm going to point out. I mean, you calculated the means correct. That's not the issue. The issue is the way you plotted the charts. You calculated.
Yeah.
You calculated everything correctly. So, you know. So I'm going to focus on explaining what standard deviations mean, and you calculated the coefficient of variation, what have you. Okay. All right. All right. So let me go through then the process of explaining things to you. Let me go on the next homework assignment so we can do that correctly.
Okay.
Which is this homework assignment that is due this weekend, because you can use it to learn what went wrong in the other one. All right.
Yes.
So
I'll start that.
this is the homework assignment about clubs. Okay. And it's a consumer satisfaction survey, which is an application of what you would learn, say, if you take a course in marketing, especially marketing research. And I'm going to pull up the data. Okay. And I'm going to do a part of the problem just to explain things to you. Okay.
All right. I'll pull up the data as well.
Yes. So I will share my screen.
Okay.
All right. Are you see my screen now?
Yes, I see.
All right. You see my screen?
Yeah, I see your screen.
Okay. Now, this is the kind of thing that, we do in business applications, business and economic applications. And it's a consumer satisfaction survey. Okay.
Mhm.
All right. Now, first of all, let us, talk about the meaning of a mean. A mean is simply an average. So that, it's very simple language. We use mean as a technical term. And even the word mean also, people understand that in common language, but it's simply an average. People understand more the average. Okay. Now, in statistical analysis, much of statistical analysis is really, there are two types of statistical analysis. One, one type is the what do you call it? The descriptive statistics, and the other is the inferential statistics. And the descriptive statistics simply summarizes data and shows you the summary results like averages and standard deviations. They show you medians, which is simply the value. If you set up all the data in one straight line array, and so the value that's in the middle of the data, for example, if you have 3, 4, and 5, 4 is in the middle of the data because 3 is before 4 and 5 is after 4. So 4 is the value that's in the middle. If you have 3, 4, 5, 6, and 7, 3, 4, 5, and 6. So you have 3, 4, 5, and 6. So, again, 3, 4, 5, 6, and 7. 5 is also in the middle. Okay. If you have, 2, 3, 4, 5, and 6, then 4 is in the middle. Okay. Because there are two values ahead of 4 and 2 values after 4. Okay. So those are the kinds of statistics you present in what do you call it? Descriptive statistics. Now, in inferential statistics, we now look at what happens in statistical analysis. In statistical analysis, we have the population. For example, all the students that are registered at McGivers College is the population of students of McGivers College. Every single student. You must count every single student for you to say you have the population. Now, suppose we are thinking about the students that came to school today. And there are nearly 4,000 students at McGivers College, or 3,500. And only 600 came to school today. Then the population of students that came to school today is 600. All right?
Yeah.
Okay. Now, in statistical analysis, we have the population, then we have the sample. And so now out of the 600 students that came to school today, suppose that you encounter a group of students in a room, and there are 30 of those students in the room. Those 30 students represent a sample, because a sample is simply a selection from the population.
Yes.
Okay. So at this stage, these first 3 or 4 weeks, or even 5 weeks, we're going to be talking about descriptive statistics, which is we summarize the data, in such a way that you can, take a look at it and have an idea the structure of the data. Now, so what we're doing here in this homework assignment is that we are looking at a descriptive situation. Okay, that's the problem that we have is a descriptive statistics. So we look at a consumer satisfaction survey. We ask ourselves, what is the average age of the males in this survey? What is the average age of the females in this survey? And then we calculate the standard deviation. Okay, so now statistics analysis is not just about calculating those summaries and looking at them, but giving an interpretation to what they mean and using them to solve business problems. And you can use statistical analysis to solve problems in agriculture. You can use them to solve problems in medicine. If you know very well that, for example, in medicine, every medication does not work for everybody.
Absolutely right.
Okay, doesn't work for everybody. The question then becomes, why does it not work for everybody? Okay, if you go in the area of agriculture, you apply fertilizer to this piece of land, you apply the same fertilizer to another piece of land, the yields will be different because of different contents of the soil. So, and so you can calculate the average yield in this soil and average yield in that soil and ask yourself, what is the difference? Why is it that there is a difference? You go to Brooklyn and you go to the Bronx, you calculate the average incomes of people, you calculate the average incomes of African Americans,
Culture.
Asians, you know, and you say there's a difference in their average incomes. That is descriptive. You are not explaining yet, why they are different, but you're looking to see if there's a difference, at least on the face of it, okay?
At that point, you're just taking the sample now.
Yeah, we take a sample, yes, because you will not be able to truly determine the population of Brooklyn, okay?
Got it.
And so in a statistical analysis, when we do inferential statistics, which we will get to very soon, we rely on a sample for the simple reason, for a number of reasons. One, if you try to get information from the entire population, you might run out of time, and the information that you will get will be overtaken by events. Two, it might be too costly to get the information from the entire population, okay? Three, it might be practically impossible, conceptually impossible to really determine the population, because people move in and out of Brooklyn. This is number one, okay? Suppose you go to a fish pond. There are certain characteristics of fish that will come into a fishing area, but the fish come and go, okay?
Yeah.
And so you will not be able to say this is the exact population of the fish there. So sometimes it is practically impossible to measure an entire population. But for academic purposes, we can say, okay, let us assume that this is a population. So now, let's take it that we're using a sample here, but we're not doing any kind of testing using the sample to make judgments about the mean. We're just summarizing the statistics and then saying to ourselves, this is what it is. This is the average age of males. This is the average age of females. Okay. The other thing that we ask for here is the average number of visits between males and females. Okay. So we're going to calculate those two and say which gender has the greater variation in number of visits and in age. All right. So,
yeah.
So let us, so two things that you should bear in mind. We're going to calculate the average age and the average number of visits. So I'm going to stop this share and I will pull up the Excel.
The Excel sheet now?
Yes. All right. So you can see my screen.
I see it.
Okay. So this is
okay.
Yeah. This is the data. Okay. And
yeah.
See, okay, here is gender. One represents females, and two, let's see, and two represents the males, or vice versa. Let me see what the information says. Okay. Okay, one represents the males and two represent the females. Okay, all right. So what we're gonna do is we calculate the average. Okay. Calculate the average for the males, and so we say equals average for the males Let me just take F2.
Yeah, because it's really long. The data is like 1,000 and something.
No, I think it's 100. F2.
Yeah, scroll down. It go all the way to 1,216.
Is it?
Mm-hmm.
Gender. F2 to F369. Oh, I didn't know that. But average F369.
So when doing the assignment, should we stop at 369?
No, that is the average for the 2 F369. That is, yes, for the males.
Maybe I opened the wrong one. Let me see.
Oh, excuse me. It's not F that we're using. The average age is H2 to H369. So we'll calculate H2 to H369. Okay, so the average age of the males, okay,
35.17.
is 35.17. Okay. And so the average age for the females would be from 369 to 1215. Okay. Be from 70 to 15 is 34.8. So the average age for the females is 34.8. Okay. So now we calculate the standard deviation. So what is the purpose? The standard deviation tells you the variation in the values of the data. Okay, that is how widely spread. For example, if you have data, let us say we look at data for say Brooklyn,
Okay.
and the average income, the lowest average income is 15, and the highest average income is 100. Okay. All right. And then we compare that to say the average income in Manhattan. And the lowest is 80 and the highest is 100. Okay. So you will see that there's a wider variation in the Brooklyn average and the Brooklyn data values compared to the Manhattan data values. Okay. Because all the values in Manhattan are bunched up between 86 and 100, while the data in Brooklyn goes from as low as 15 to as high as 100. So the variation is high. But you ask me then, what is the purpose of this? This is why I said, when we do statistical analysis, we don't just like bring numbers down. We ask ourselves, what is the use for these numbers? Okay.
Yeah.
So here we have the average. Okay. And here we have the standard deviation. Okay. So here we calculate the standard deviation. So it was STD dot S H2, 2, H369, STD.
I think it's STD EV.
S.
Then
Let's see. STD. Equals STD. Oh, STD-EV.
yeah, EV.
Yes. Okay. H2, 2, H369. Okay. And so we get 11 point. And then this is H370 to 1215. Okay. All right. So now we have a standard deviation. Okay. Males and females. So
Okay.
now I would also ask you to calculate the coefficient of variation. Okay. And the coefficient of variation is the mean over the standard deviation, right? It
Yeah,
shows
so
you the relative rate of dispersion. Okay. And what are the applications of this coefficient of variation? So explain to students, the applications indicate how how dense the spread is.
yeah.
Okay, it's a measure of dispersion in the sense that it standardizes the relative density of the data. All right.
Yes.
Yeah. So now, why is it important? Okay, it tells you for each 1 unit of mean, what is the amount of standard deviation? That's what it tells you. You can apply it in a number of ways in business and economics. One, you can use it to measure risk. Okay, you can use it to measure risk. Okay, this is one. You can use it to measure, for example, the variation in opinions. All right.
Okay.
For example, if you are doing credit analysis for 2 different businesses, and say in accounting, we do things like accounts receivable aging. So you compare 2 businesses, okay? Both of them have an average collection period of, say, 30 days. Both of them have an average collection period of 30 days, right? So you're comparing 2 businesses, okay? They have an average collection period of 30 days. And it's okay, average collection period of 30 days is fine. But one business has a coefficient of variation of, say, 4, which is the average collection period over the standard deviation is 4. And the other one has a coefficient of variation of 1.5. It means that the one with the coefficient of variation of 4 has a wider spread around the mean. Okay?
Yeah.
And so that one is more risky. The higher the coefficient of variation, the higher the level of dispersion. Understand that?
I understand that part.
Okay. So suppose, in fact, I asked a question to, it's a measure of consistency of the value of the data. Okay. If you have, say, 5 points of data, one has 2, 3, 4, and 5, right? Okay. Now 2, 3, 4, and 5, and 6 has an average of 5, right?
Yes.
Okay. Now another one has 1, 1, 1, 5, 4, 4, 4. You see that the dispersion in the second set of data is higher. Okay.
Yeah.
So now I asked students a trick question in an exam. I say somebody surveys um, staff in a hospital. Okay. I say Count Dracula surveys staff in the hospital. And what does Count Dracula find out? Count Dracula surveyed the satisfaction levels are different about different kinds of policies in the what do you call it, in the hospital.
Mm-hmm.
So if Count Dracula wants to divide the employees, which of these issues would Count Dracula use? Count Dracula will use that particular kind of policy where the nurses have a wider variation in the coefficient of variation, because that's where they differ the most.
Okay.
You get the idea? Okay.
I get that. It'll be easier.
Okay. Because the coefficient of variation on that particular policy issue is wider. The same goes for if you want to invest. We apply it in investment. We apply coefficient of variation in investment.
I didn't know that. Okay.
Yes, of course. If you look at, say, 2 different stocks,
Yeah.
both of them have the same average return of, say, 10%. But one has a coefficient of variation of 5, one has a coefficient of variation of 1.5.
Okay.
If you want to minimize your risk, you will invest in that stock that has a coefficient of variation of 1.5, because the spread on the data on the return is less.
Okay.
Because this one returns 5% today, the next day it returns 20%. Then it returns minus 10%, then next time it returns 40%. Right?
Yes. Okay.
So if you invest in the asset that has a wide spread, you are more likely to lose your money.
Correct.
But you're also more likely to make a killing if you're lucky.
Yeah, exactly.
Okay. But if you invest your money in the asset that has very small variation, you may never get rich out of it, but you never lose a lot of money either.
Yeah, so it's more safe.
It's more secure. Okay. So the coefficient of variation is equal to the average, which is L2 over K2.
The standard. And
okay, which is the mean over the standard deviation. Okay, so you can see that the coefficient of variation of the age of the males and females is about the same.
okay.
One is 3.09, one is 3.1. Okay, so let us calculate the average for the number of visits. Okay, visits is in J, equals average J2 to J369. Okay. Okay. The males have an average number of visits of 1.75 equals average J370 to J1215. Okay. And the females have an average visit of 2.15. Let's calculate the standard deviation. Equals ST dev S J2 to J369. All right. And equals ST dev dot S J370 to J1215. Okay. So now we calculate the coefficient of variation of the number of visits. Okay. So you can see that when you come to the number of visits of females compared to males, you can see that the females visit the gym more often.
What's more?
They average 2.15 visits per week. You see that?
Yeah, I see it.
Okay. And the males average 1.75 visits per week, right?
Yeah.
But when you look at the coefficient of variation, you find out that the coefficient of variation for males,
the females is way more than the males.
It's really more than the males. Okay.
Yeah.
What could be the reason why, even though the females visit the gym more than the males, but their variation of their visit, the variation in the number of visits is less consistent than that for males, right?
Yes.
Okay. It could be any number of reasons. It could mean that the females have more distractions, like childcare. Okay? No, we're still living in a society, where taking care of the kids is something that we still leave more to the females than to the males.
Yeah.
It might just be that, okay? Because when you come to look at the average age, you find out the average age is not much different between the two. When you look at the variation in the age, you will say that the range of age of males and females that come to the gym is also about the same, 3.09 compared to 3.13. If we reduce this to, say, 2 decimal places, you find out it's not much different, 3.09 and 3.14.
Yeah.
Right? Okay. But so why is it that the variation for females is higher than the variation for males? And so we have come up with some kind of a reason, an explanation. All right? Okay. Okay. Now this is for those who are in the club. Okay. If you look at other data, so suppose you collect data from a workplace. Suppose you collect data from what do you call it? Maybe from a social group, okay? This is data from a particular gym, and they're just looking at general customers from the population, okay? So, but when you calculate coefficient of variation, you use it for different things, okay? Like I said, you can use it for conflict resolution, okay? You can use it for conflict resolution, like if you come among union workers, you want to find where their opinions are most inconsistent. Okay. Okay. You use it to say do credit analysis. Okay. You want to know which customer is more risky. Bankers use it. Okay. When they want to extend credit to their customers. Okay. They use it and say this person is more risky. Use it in investment analysis, as we said, to ask yourself which of these two assets is more risky. So this is essentially, the lecture I want to give today. If you have any questions, then ask me about it. I'm going to post this lecture for everybody, and so if you have questions, ask me.
So far, I'm getting the hang of it.
Okay, all right, no problem. I'm glad that you came by. And so I'll see you all next week. Okay.
Same time, same place.
All right then. Bye.
Have a good one. Bye.
You too.